There is something in the dark, roughly 1,500 light years from where you're sitting right now, that does absolutely nothing. It doesn't glow, it doesn't scream, it doesn't pull nearby matter into a violent accretion disk of fire and radiation like the black holes you've seen in movies and textbooks. It just waits, perfectly silent, perfectly invisible. And if it ever woke up, if the physics of this universe shifted just slightly in its direction, everything we've ever known, every planet, every moon, every molecule of life could be erased before we even had time to look up. Its name is Gaia BH1. And it is the closest known black hole to Earth. If this is the kind of thing that keeps you intrigued and hungry for answers, subscribe and hit that like button. You're exactly where you need to be. For most of human history, we had no idea it was there. Black holes that actively feed, that consume nearby gas and stars, announce themselves with X-rays and jets of plasma visible across galaxies. We built entire detection systems around that violence. We knew how to find the loud ones. But Gaia BH1 is what astronomers call a dormant black hole, a sleeping giant. It produces no radiation we can directly observe. It has no accretion disk. It isn't tearing anything apart. It's simply a region of space-time where a massive star once burned for millions of years and then collapsed inward in a final silent act of annihilation. The only reason we found it at all was because of a wobble. In 2022, a team of astronomers analyzing data from the European Space Agency's Gaia telescope noticed something strange about a sun-like star in the constellation Ophiuchus. The star was moving in a subtle oscillating pattern, a gentle, rhythmic sway that had no obvious explanation. Stars don't wobble on their own. Something had to be pulling at it. When they calculated the source of that gravitational influence, the numbers were unmistakable. A black hole, 10 times the mass of our sun, right in our cosmic backyard. If that discovery made your mind stop for a moment, this channel is where those moments live. Subscribe. We go deeper every week. Let's understand what 10 solar masses actually means. Our sun is a star so massive that 1.3 million Earths could fit inside it. Its gravity holds 8 planets, hundreds of moons, billions of comets, and the entire architecture of our solar system in a stable orbit. The sun is, by every measure, incomprehensibly large. Gaia BH1 contains 10 of those, 10 times the gravity, 10 times the mass, compressed into a sphere roughly 60 kilometers across, smaller than the distance you might drive on a highway in an hour. Imagine taking everything our sun is, its light, its heat, its 4.6 billion year history of nuclear burning, and crushing it down until it vanishes from visible reality entirely. Now do that 10 times over and fold all of it into a point of infinite density smaller than a mid-sized city. That is what Gaia BH1 is. That is what has been sitting 5,500 light years away, in silence, for longer than our species has existed. To give that distance some texture, the fastest spacecraft humanity has ever launched, Voyager 1, traveling at roughly 61 kilometers per hour, would need approximately 26 million years to reach Gaia BH1. It is close by astronomical standards. On any human scale, it is unreachable. But in the language of the galaxy, it is essentially our neighbor. And before 2022, we had no idea it was there. Here is where the story becomes genuinely unsettling. Gaia BH1 exists in what astronomers call a binary system. A companion star, a star remarkably similar to our own sun in size and temperature, orbits the black hole at a distance roughly equivalent to the distance between the Earth and our sun. Think about that geometry for a moment. A star very much like ours in orbit around a black hole, at a distance very much like our own orbital path, close enough to be gravitationally bound, but far enough that the black hole, in its current dormant state, isn't actively consuming it. The star exists in a kind of uneasy equilibrium, close enough to feel the pull of something 10 times more massive than its own sun, far enough that the tidal forces haven't yet begun to stretch and shred it into a spiral of superheated plasma. This is what sleeping means. Not safe, not harmless, simply not yet hungry. Dormant black holes like Gaia BH1 are notoriously difficult to detect because they don't broadcast their presence. The estimates suggest there could be hundreds of millions of them scattered throughout the Milky Way. Invisible, silent, drifting through the galaxy with no observable signature beyond the gravitational fingerprint they leave on nearby matter. We found one by accident in data we were using for an entirely different purpose. The question that follows naturally and uncomfortably is, how many more are out there that we haven't found? How many are closer than we think? Now let's talk about what would happen if Gaia BH1 were to wake up. Under current conditions, our solar system is in no danger. The physics are stable. The distances are immense. There is no mechanism by which Gaia BH1, in its present orbit within the Milky Way, would migrate 1,500 light-years through the galaxy and arrive at our doorstep within any time frame relevant to human civilization. But the universe doesn't operate on human time scales. If, through some rearrangement of stellar dynamics, through a close gravitational encounter, through the slow drift of orbits across millions of years, Gaia BH1 were ever to draw near enough to our solar system to exert significant gravitational influence, the consequences would unfold in a specific, brutal sequence. First, the outer planets, Neptune, Uranus, would begin to drift. Their orbits, maintained for billions of years by the precise gravitational balance of our solar system, would stretch and distort. Then Jupiter, then Saturn. The gravitational choreography that keeps the inner planets stable would begin to unravel. Then would come the tidal forces. At close enough range, the difference in gravitational pull between the near side and far side of any object, planet, moon, or person, becomes so extreme that it overcomes the object's own structural integrity. This is what astronomers call spaghettification. Matter doesn't fall in whole. It stretches. It elongates. It becomes a thin stream of superheated particles spiraling inward. The sun would feed the black hole last. And in doing so, it would briefly outshine the entire galaxy. None of this will happen. The probability is, for all practical purposes, 0 within any time frame that matters. But the physics are real. The mechanism exists. And the universe has 8 billion years of history that suggest it has no particular attachment to the survival of any one star system. What Gaia BH1 really represents isn't a threat. For centuries, we assumed the night sky was mostly empty, a vast, sparse collection of stars separated by incomprehensible distances, safe in its emptiness. We knew black holes existed, but we imagined them as rare, distant, obvious objects that announce themselves through radiation and chaos. Gaia BH1 suggests something else entirely. The galaxy may be full of sleeping giants, invisible objects of extraordinary mass, drifting silently through the dark between the stars, detectable only by the faint gravitational whisper they leave on the matter around them. We found one 15,500 light-years away by pure chance, while looking for something else. The implication is stark. There may be others far closer that we simply haven't looked at the right way yet. This is what the universe does. It hides things in plain sight. It buries the most extraordinary phenomena in silence and darkness, waiting for a civilization curious enough and patient enough to notice the wobble. Tell me in the comments, does knowing there's a sleeping black hole 1,500 light-years away change how you feel when you look up at the night sky? I read every single one. We think we know this galaxy. We've mapped its arms, cataloged its stars, sent our machines into the dark between the planets. We've captured the shadow of the supermassive black hole at its center. We've looked back to the edge of the observable universe. And yet, something 10 times the mass of our sun was sitting 500 light-years away, in a corner of the sky we've been watching for centuries. And we only found it because it gently tugged on a star. The universe doesn't hide its secrets. We just haven't learned how to listen.